All right, another integral properties video. This is the second last one. So we'll get through this one, and then we'll do the next one, and then we're all done. I just wanted to say as well, if you're finding these videos useful, it would be good if you could subscribe to the channel. Yeah, I enjoy making the videos, but it would be good to know that some people are watching them. So if you're finding it helpful, that would be good. The idea is to hopefully have pretty much all the content in year 12 methods at least covered by some point. So if we want to work towards that, subscribing would help. All right, so let's have a look at this rule. So we've got the integral from a on k to b on k of f of kx dx, and we're saying that's equal to 1 on k multiplied by the integral from a to b of f of x dx. Now, what we could consider here is a situation where we're basically taking a dilation factor by 1 on k from the y-axis. So that's what we have here. You can see in green, we've got the line, the function f of x equals log e of x. And then in red, we've got the function f of 3x, which is log e of 3x. So again, I could have picked any function, but these ones are just some nice ones to look at. Okay, let's break it down. Let's look at the right-hand side first. So the right-hand side says that 1 on the dilation factor is equal to the integral from a to b of f of x. So what we're going to say is we've got 1/3 multiplied by the integral from 3 to 6 of log e of x. Okay, and that is, if we just consider the right-hand side for now, that is just a number. That's just an integral, that definite integral that we could evaluate. And, we take 1/3 multiplied by the definite integral, which is this, and then we get log e of 12 minus 1. And so what we're saying is that 1/3 of this green area is equal to approximately 1.48. Okay, but what that's equivalent to saying is this. Since the dilation factor is by 1/3 from the y-axis, if I take the bounds, which was originally 3, and divide it by 3, so a on k gives us 1, and then take 6 and divide by 3 gives us 2, and we're saying that that's log e of 3x dx is going to be equal to, what we just said. And that obviously turns out to be true. So we get log e of 12 minus 1, which is obviously the left-hand side equals the right-hand side. So this one can be a little bit trickier to wrap your head around, but I suppose graphically what we could finally say is that 1/3 of this green area is the red area, and we can probably show that. Yeah, we can see that this area here is 4.45 and this area here is 1.48 approximately. So they are 1/3 of one another. Okay, so if you're dilating by a factor of 1 on k from the y-axis, you can multiply your original function by 1 on k. All right, hopefully that makes sense. A bit of a tricky one, but a useful property that can come in handy sometimes.